So in this video, we're going to talk about limits and introduce them on how to solve them using algebraic techniques rather than graphs. In the last video, we talked about finding limits with graphs, but as you can imagine, it's dependent on how well you can draw, how well you can interpret someone else's drawing. You know, is it crossing at 1 or 1.5 or 1.1? Or it's kind of hard to tell with a graph. And there's a lot of interpretation in there. So as you can imagine, the majority of what you're going to do is you're going to do some sort of algebraic technique or use some sort of trig rules that you knew before in order to come up with an exact value for the limit that is not dependent on somebody's drawing ability to get you a correct answer. So let's go on over and try some of these problems. There's techniques to this. We're going to make lists as we go through, as we progress. There's a series of limits, videos, several different techniques to use. And as we go through them, then we'll just add them to our list for what we can do for techniques. At the end of this video, there is a link to a worksheet practice problems that you can do to see how well you're doing with these in addition to your book. We'll also be talking about presentation styles and all sorts of things. Now, here's the basic definition for a limit. So it says, suppose f of x is defined where x is in some open interval that includes number a, although it may not be defined at a itself. Then we can state that the limit of f of x as x approaches a is equal to L. And this first one, where you have a with no plus or minus, it's a two-sided limit. And if you set down here, the limit from both sides is equal to some value L if and only if the left-hand limit and the right-hand limit are equal. Now, if you're not sure what this means, you need to go back and look at the previous video, which the link is at the end of the video if you need to see it. The previous video goes through and talks about what these left-hand limits and right-hand limits and two-sided limits mean. So if you're not real sure, go back and look at those. All right, so what happens is if you have something, you know, kind of fairly simple like a polynomial, and you are wanting to take the limit of it, then what you do is you can use what's called the substitution principle. This should be in your book. And the substitution principle says if I'm trying to take the limit at some value, let's say 2, of something like x squared minus 1. Now, x squared minus 1 is a polynomial. There's no negative exponents. It's actually a parabola, right? So if I'm wanting to know what the limit is as x approaches 2, if 2 is in its domain, then I can just use the substitution principle and substitute in the 2 because x is going to actually get to 2 because it's in the domain, right? And so 2 squared minus 1, that's 4 minus 1, this is 3. Now remember, this is a y value, and this is talking about x. So you're going to input x, get an output of a y, that's your limit. Now, I'm going to start talking to you about formatting. If you're lucky enough to have a teacher that is collecting homework, handwritten homework, and is evaluating it and giving you feedback, that's a great blessing because the feedback is supposed to tell you some corrective action if you need some, maybe a misunderstanding on your part. So use that as a chance to interact with your teacher. Don't just copy down the solutions manual. If you've managed to find one, the teacher has one too. The teacher does not need another version of the solutions manual and will get probably a little cranky if you're just writing down the solution manual's process. I know I get cranky. And so don't do that. All right. It's kind of insulting to the teacher. It's a waste of the teacher's time, and it doesn't provide you any input. So use this as a chance to get input from the teacher. If you don't know what's going on, give them your best guess, and hopefully they'll write a little note next to the side of it that tells you what went wrong. So if you have one of those teachers, format is usually huge. It is huge for me. I'm actually an engineering teacher, teach math mostly because I love it best. And so format, huge. You don't give me a well-structured answer, you're not going to get full credit. Just like your English teacher doesn't give you full credit for a poor sentence. So here we go. The limit as x approaches 2, I don't do very good arrows, of this function is equal to 3. This is proper form for your answer. Don't just write 3 and box it in. Okay, so you need a complete sentence. Left-hand side equals a right-hand side. That's a lovely complete sentence. Teacher's going to love you. You just put a 3 and box it in, and some teachers will count off, including me, for not making a full statement. Okay, now also you'll see me working down the page instead of across. It is bad form, despite what the books do sometimes, to write like this. Okay, see how there's multiple equals here in this one line? Sometimes books do that because they're trying to save space, and you, in the days of print books, have fewer pages, and they'll write this long, but this is like a run-on sentence in English. Your English teacher didn't like run-on sentences, neither will your teacher like run-on math. So hopefully your teacher's not doing that, okay, themselves. So work down the page. Right? Be sure you only have 1 equals per line. Be sure you box in your answers, and be sure that you have a complete statement at the end. And then you'll get full credit. And appreciate your teacher if they have standards like that, because they are teaching you something that is going to be a life skill that you need. It makes you more organized, makes you make a better impression. It's just wonderful all the way around. Okay, so let's try a different one. The limit as x approaches -2. Let's try -2. Of x squared minus 4x plus 6. Again, this is a polynomial. And so since it's a polynomial, its domain is all real numbers, -infinity to infinity. So any x value is allowable and is used. So you can use the substitution method or principle and just substitute it in. Be careful about squaring negatives. All right. And I'm going to just show you, a lot of y'all do this on your calculator, can do it in your head, but I'm just going to write down here for a second. So remember, a negative square is positive. This is +8. Okay, so this is going to be 18. Don't just box in the 18. Be sure you make a full statement. Be sure you only have 1 equals per line. And careful with this limit. All right, so see how I already substituted in the -2. Once you substitute in the -2, you can leave the word limit off, or this limit, okay? Until you substitute in the value, you have to keep up with it. There was okay, so let's look at this one more time. I just want to be sure. All right, so you have a limit, you look at your function, and you say, is this number in this function's domain? If it is in that domain, you just substitute it in by the substitution principle, okay? You do not have to do this line. You can just do that in your head. All right, and then you have 18. And then be sure and make a nice boxed in answer. Okay. Now let's do another one. The limit as x approaches 5 of x plus 3 over x minus 2. Now this is not a polynomial. It does not have a domain of -infinity to infinity. Its domain is restricted. You cannot have 2, correct? Because you cannot have 0 in the bottom of the fraction. If this had been a 2, and I was asking you about 2, there we would have to do something else, okay? But since 5 is not part of the restriction, we can just, again, substitute it in, but you can only substitute it in if it's part of the domain, all right? And the only thing that's restricted is x can't be 2. So you would have 5 plus 3 over 5 minus 2. I like to see my students substitute it in even if you can do it in your head, because if by some odd chance you're having a bad day and what you're doing in your head is incorrect, I can at least give you partial credit for having set it up correctly. So this is 8/3. And again, even though you have to do a lot of writing, it's good form to make a proper sentence and then to box in your answers, right? Let's do another style. All right, now there's no restrictions on this one's domain. So -1 would be in the domain. We just substitute it in. And once we substitute it in, we can leave off that LIM, the limit with the x approaches -1. So this is the absolute value of 1 plus 4 plus 5. You don't have to put that step in. All right. So this turns out to be 10. Remember to make a nice complete sentence. If you leave out this part about x approaching -1, it's not a complete statement. You'll have points taken off. Also, if you do like this, the limit as x approaches -1 is 10, I take off points. So will your teacher. Okay, because it's like the limit of what? Okay, the limit of what? It's like saying the square root of something is 2. What's the something? That's kind of important to know. So you have to say what you're taking the limit of, and you have to make a full statement. Right. Now, since this is in the domain, legitimately, okay, the limit, if they had said what's the limit as x approaches -1 from the left of this, it would be the same answer. Sometimes teachers will put a left or a right hand limit in just to see if it bugs you. Okay, because if it's bugging you, you don't really have a completely firm grasp on what's going on with this left hand, right hand, and two-sided limit. So they'll put that in there just to see if it bugs you. A lot of times it does. I'm one of those who puts it in there. And I actually thought it would be a free question the first time I used it. Kind of like, okay, here's a give me 5 points question. And it really threw a lot of students off. So keep in mind that whether it's a right hand limit or whether it's a left hand limit or whether it's a two-sided limit, if that number is in the domain, okay, now, it's you can just substitute it. Now there is some some caveats to this. Now, this is not one size fits all. Okay, if you had something that was not all real numbers, okay, and it started right here at 0, 0, okay, then the limit as x approaches 0 from the right of this function is 0, okay? The limit as x approaches 0 from the left, well, there's no function, okay? So if you don't have any of the graph to that side, then you can't say it's the same, but this graph exists on either side of -1. So the two-sided limit and the right hand limit and the left hand limit would be all matching. Okay. Now, one of the other forms that teachers like to use in books is this version of the absolute value. Now, see how these look an awful lot alike? Okay, x minus 1 over x minus 1, but one of them has an absolute value bar. You cannot say that this x minus 1 that's on the bottom cancels the absolute value of the x minus 1 that's on the top, because the x minus 1 on the top has an absolute value, and that should make you kind of suspicious as to what does that mean, okay? And so don't jump for this. Kind of work this one through. You'll see this not fairly often. I wouldn't say it shows up like 80% of the time, but I'd say it shows up, I don't know, 5% of the time on the first test, and that's worth 5 points to know. Okay, so what is this thing's domain? Again, you can't have 0 in the bottom, so x minus 1 can't be 0, so x can't be 1. So that's a problem. Okay, that's a restriction. But I'm not going to talk to you about that point. Okay, I'm going to talk to you about 0.5, which is not at 1. So I can just theoretically substitute it in. Now, I want to work through this and show you what happens with these absolute values. So you would say, I can use 0.5 because that's not the restriction. So 0.5 minus 1 over 0.5 minus 1. Okay, now 0.5 minus 1, excuse me, is a negative 0.5. And so on the bottom, you have negative 0.5. So the absolute value of negative 0.5 is a positive 0.5. This is a negative 0.5. So it is kind of like a version of 1, right? Except this is a negative 1. So when you see this, you can anticipate that maybe there's a version of 1 in there somewhere, but whether it's positive 1 or negative 1, you need to really either understand this very well or work it out. And I'll be honest with you, when I'm taking a test or when students take tests, if you're not fully aware of the nuances of a problem, it's better to work it out. Okay, it's better to take a little bit of time and be right than to be speedy and be wrong. At least that's my opinion. And I have some of these on the worksheet, the links at the end of the problem of the video so that you can practice some of these. But let's talk about another, just a variation on this, and then we'll move on to other things. Okay. So when you start trying to do limits, the very first thing you should decide is, can you evaluate this function at the number that the limit is curious about? Okay, which means you have to know what the domain is. So you look at it and go, I wonder if I can just substitute the negative 1 in. And since the restriction on the domain is that x can't be negative 2, you go, okay, yeah, I could do that. Now, since this is, I could use the substitution principle. So since this looks like an absolute value over something that looks kind of related to this, I want to use that concept about maybe this has a variation of a 1 in there to do this. So if I factor out a 2, right, then I could actually say, well, the absolute value of this 2 is 2. So it's the limit as x approaches negative 1 of 2, absolute value of x plus 2 over x plus 2. And see how it's got that variation on a theme of 1. So unless you're absolutely positive, let's substitute this in. So negative 1, let me put the bars back on. Negative 1 plus 2 over negative 1 plus 2. So you have 2 times the absolute value of 1 over 1. So see if what's inside the absolute value is positive, then you get this 2 times 1 over 1, which is 2. You okay so far? All right. Now, what if this had been the absolute value of a negative 2 times x plus 2? When you pull this out in front, you go, the absolute value of a negative 2 is 2, and it would have looked like this. So be careful. There's one like this on your practice problems that the link's at the end of the video. All right. What if they say, what's the limit as x approaches a 2? I think I'm stuck on a 2 of e to the x. Well, the e function looks like this. So it really kind of helps if you remember the function's general shape. Its domain is all real numbers, right? Negative infinity to infinity. So I can use the substitution principle and just sub it in. Now, this is an exact answer. All right. The approximate answer is, if you run it on your calculator, 7.3891. This is approximate. So if the book or your teacher says approximate it to the nearest 10th, okay, you would have 7.4. Okay, but this is approximate. In general, traditionally, and traditionally means that it depends on your teacher if they're a traditional kind of teacher or not. So traditionally, if they do not ask you to approximate it, you leave it exact, and you would have left your answer this way. If they say approximate it, then you can approximate it. But be careful, okay? Traditionally, you're not supposed to approximate unless somebody asks you. Okay? Now, so if you have something, a function, and the number they're curious about is in its domain, then you can use the substitution principle and sub it in. At the end of the last video, I left you with this thought. If you have y is equal to x squared minus 4 over x plus 2, you know there's a restriction on the domain. X cannot be negative 2, correct? But if you graph it, okay, so see how this is red. This is that Desmos calculator again. Here is the graph that is for x squared minus 4 over x plus 2. And it will draw what appears to be a line, except that right here at x minus 2, there actually should be a hole. And some of your calculators, depending on the settings, will just fill that in and just zip right through it and play connect the dots and make it look like it's there. But if you look under the table where you graph, it will say error, because you can't put negative 2 in here, because negative 2 plus 2 would give you 0 in the denominator, and that's not allowed. Okay, so your graph, again, like I said at the beginning of this video, sometimes graphs are not an accurate representation of what's going on, okay, because this graph just rips right through it. And if you look at this green one, this is actually the graph for y is equal to x minus 2. So see how the graph for x minus 2 looks just like the graph for the rational function? Except the x minus 2 is a line. There's no restrictions on x minus 2, so there's no hole here. It's solid. So we can theoretically use this simpler graph to talk about what's going on here, as opposed to the graph that has a hole in it. Okay? And they call this, because of this x squared minus 4 over x plus 2, some rational functions have what's called removable discontinuities. Okay, so it's discontinuous at minus 2, but sometimes we can remove them. Okay, so it's a removable discontinuity. And the way we would be able to do that is if you look at this function. The x squared minus 4 actually factors. It's the difference of two squares. And if you've forgotten how to factor, at the end of this video is a link to another video on how to factor, and a kind of a formula sheet that gives the various styles of factoring and how to manipulate them, kind of a summary. So you should look at those if you're a little rusty on factoring. So x squared minus 4 factors down to x plus 2x minus 2, and these two x plus 2's reduce out. Some teachers kind of get very upset if you say cancel. So canceling's fine, but if your teacher doesn't like that, don't use it. Okay. So this reduces to the x minus 2. And so this is why this, which is actually this graph, is represented by this, because you could remove this discontinuity by using algebraic manipulation, factoring it and reducing it. Okay? So in other words, if I had said, what's the limit as x approaches negative 2 of x squared minus 4 over x plus 2, we would look at it and go, can I use the x minus 2? Is x minus 2 in the domain? No, can't use the x minus 2 because that would give me minus 2 plus 2 in the bottom. I don't care what's going on the top because I can't even get past the denominator. That would give me 0 in the denominator. It's not in the domain. So our first trick, if you want to call it that, first technique, first tool, is maybe I can factor it and remove the discontinuity. So you would say, oh, x squared minus 4 factors down to x plus 2, x minus 2. Because we have not substituted in the minus 2 yet, you must keep writing limit and what it's approaching. If you leave this out, because you don't want to write it all these times, your teacher should, and most likely will, count off, because you're not making a proper statement. You've changed the problem. You can't do that. All right, so I'm still doing my limit. You have to say this every time. Okay? Then this x plus 2 cancels this one or reduces out, leaving you x minus 2. If you just write the limit of x minus 2, technically what you're doing is just taking the limit of this x. Now, in this case, it would get you the same answer, but it could be the wrong answer if it was a more complicated problem. So I can substitute the minus 2 in now. So this is minus 4. So to make my nice complete sentence, the limit of the original function can be calculated by finding the limit of the reduced function. Because you can see right here that as x approaches minus 2, the limit, the y value, is minus 4. You don't actually have to be able to get there to have a limit. You just have to approach it. So let's try a few problems. So let's try the limit as x approaches negative 3 of x squared plus x minus 2 over x squared minus 9. Now, you can stop the video at any time, try it yourself, get an answer, then turn the video back on and see if your procedure in mind's the same. And I would encourage you to do that. Again, if you don't remember how to factor, because there should be several of these problems on your first test, and there should be homework over this. So if you don't know how to factor, find the link that refers you back to the page that says, if it looks like this, do that. If it looks like this, do this. So there's a handout with shortcuts on it. And then I'm going to create a video that talks to you about how to factor. So this, I can't, you look at it first and go, can I just substitute in the negative 3? So this would be negative 3 squared minus 9. So you don't have to go through and figure out what the domain is. You can just substitute it in and see if it works. And this would be 9 minus 9. That would give me 0 in the denominator. This is not allowed. So I cannot use the substitution principle and substitute it in. So, but my teacher's asking me about this. So let's see if there's some way to remove the discontinuity. So you would say, well, let's try factoring. And on the bottom is the difference of two squares. So you'd have x plus 3 times x minus 3. On the top, you have a trinomial with a lead coefficient of a 1. So you would say what multiplies to -2 and adds to 1. So you would have x plus 2, x, I'm sorry, this is supposed to be a 6. What multiplies to -6 and adds to 1? So you would have x plus 3, x minus 2. Okay. Now, do you see how if you substituted in the -3, this is the part that's going to give you 0, right? This part is not going to be 0. So what you're trying to do when you do these removable discontinuities is you're trying to remove this x plus 3 problem, okay? So this x plus 3 is going to cancel out with this x plus 3, so that removes the problem area. And now you can substitute in the -3. So you reduce it. And so you'd have -5 over -6, you'd have 5, 6. Again, get into the habit of making a nice, complete statement. If you're doing computerized homework, typically you just type in the numerical answer. I've seen some, though, where they actually make you pick the correct format. But if you have a teacher that's still picking up written homework, you're blessed, and please make a complete statement. Okay, here we go. So my list, this is how your list goes. When you take this first test, typically it's all limits. Okay, so you look at it and you go, okay, can I just substitute the number in? Is it in the domain? Can I just substitute it in? If you can substitute it in, you do so. If it's not in the domain, you have to think of something else. So the first choice I come up with is maybe I can factor it and have it be something I can use now. So you look at this and go, oh yeah, there. Okay, x minus 2 on the bottom. 2 minus 2 gives me 0, so I can't substitute in the 2. Actually, 2 substituted in the top gives you 0 as well. That's something else later down the road. If you go in for tutoring help and they tell you something about L'Hopital's rule, okay, tell them you can't use it yet. Okay, L'Hopital's rule is later. All right, so we're going to factor this. This top is the difference of 2 cubes, right? Again, I feel like a broken record. If you don't remember how to do the factoring, I'm going to make a video on how to do this, and there's a worksheet at the end. So x cubed minus 8, you have x minus 2, because that's the cubed roots of those 2 pieces. You take the first term and square it and put it in the front. First back term and square it and put it in the back. Front times the back without the sign goes in the middle. You know, your teachers in the past may have taught you different verbiage. Sometimes they call it I think they call it SOAP. Same, opposite, always positive. So this sign and this sign are the same. This sign and this sign are opposite, and this one's always positive. Okay, so they call it SOAP. Again, go look at that video if this is not ringing a bell. Okay, so the problem with the domain is this binomial right there. So luckily, this cancels out. And you're left with x squared plus 2x plus 4. Now, again, if you just write it like this without parentheses, even though some books are going this way, which I don't understand, technically you're saying, I'm just going to put 2 in right there, okay, because it only applies to what's immediately after it, unless you put parentheses. So put parentheses, and you would have 2 squared plus 2 times 2 plus 4. So you end up with 12. And then notice there's 1 equals per line. You have to use the word limit until you actually sub in the number. Then you can drop the limit. But then when you make your full statement, it looks like this. Okay, you doing all right so far? All right. So let's look at, I don't know, let's try to think of a different one. Oh, let's do this one. Limit as x approaches -2 of x squared plus 3x plus 2 over x squared minus 4. And as soon as somebody says the word limit, you go, I wonder if I can take this number and substitute it in right there. Well, -2 squared minus 4 is 4 minus 4, which is 0. So nope, you cannot just substitute it in. You should always try though. All right, so one time, just to give you a heads up, I actually did this. And I said, what's the limit as x approaches 3 of x squared plus 3x plus 2 over x squared minus 4? And 3 goes in there, right? 3 squared is 9, minus 4 is 5, you know. And I had students factoring and canceling and doing all sorts of stuff. And I was like, oh my gosh, I had not anticipated that. So y'all, don't do unnecessary work. Okay, you don't have that much time. All right, so only do what's necessary. So try it. Okay, so go, nope, can't do that. So let's try to see if perhaps this technique of factoring and reducing would work. There'll be other techniques we're going to add in. So y'all try to factor this, stop the video, turn it back on, see if you factored the way I did, and see if you got the same answer. So hopefully you're back. So what multiplies to 2 and adds to 3? That'd be 2 and 1 over x plus 2, x minus 2. Now, this factor is the one that's giving you 0 in the denominator. So it'd be lovely if you could cancel that out. And yep, it did. So you have the limit as x approaches -2 of x plus 1 over x minus 2. And now I can substitute it in because it will not give me 0 down here. So I have -2 plus 1 over -2 minus 2. Almost gave the answer. All right, so this turns out to be a -1 over -4, or 1/4. Don't forget your lovely complete sentence. Your teacher will really appreciate this. Now, when you have a fraction right here, the fraction bar kind of keeps it all grouped together so you don't have to have parentheses, but it wouldn't be wrong to put parentheses here if you want, but you don't have to have them. Okay. How about the limit as x approaches 5/2? That's supposed to be a 5. 5 over 2 of 2x squared minus 11x plus 15 over 2x squared minus 3x minus 5. All right. Now, you may not be really keen on factoring or whatever, but it is a really well-used technique and you need to get familiar with it. And a lot of people don't like fractions, but I would be suspicious about putting 5/2 in here. Okay, so if we had 2 times 5/2 squared, okay, minus 3 times 5/2 over minus 5. Now, sure, you can run this on your calculator, but let's practice some basic math. So this would be 2 times 25/4, correct? Minus 15/2 minus 5. So we wanted to make them all fourths so that we could subtract them. You'd have 50/4 minus 30/4. Remember, you multiply top and bottom by 2 minus 24 if this is 0. Okay, so 5/2 is not in this domain. So we cannot just substitute it in, which means we have to try factoring because at the moment, that is our only tool only procedure that we have as an alternative. Now, 5/2, if you remember how to factor, if your answer is 5/2, that probably tells you that one of these factors down here is 2x minus 5, because when you solve it, you get the 5/2, right? But if you don't remember that handy little hint, you're going to have to remember how to factor a trinomial where the lead coefficient is not 1 on both the top and the bottom. These 2x squareds do not cancel because they're joined to the next term with these minuses, and these pluses you can't cancel in between a plus or minus like that because they're not factors, right? So after I factored this, I got 2x minus 5 times x minus 1 and 2x minus 5 times x minus 3. Normally, when I grade these tests, it's not the initial question that is causing the problem with getting 100 on the test. It's the math that you have to remember from before. You know, all the times you were in algebra class going, when am I ever going to use this in calculus? So they're going to go back and come up with all these techniques that you used in algebra, and if you have forgotten them, they're going to very much impact your calculus grade. So the 5/2 is a problem right here. That's the one that if you put 5/2 in there, you get 0. And luckily, these cancel out. And you have x minus 3 over x minus 1. You don't need that parentheses since you have the fraction bar, but it's okay. So now you've got 5/2 minus 3 over 5/2 minus 1. And though some of y'all want to come up with a common denominator and add the tops together and add the bottoms together, there's another technique which you really need to become comfortable with, because it's going to make a world of difference in the next couple of videos, is if you have a complex fraction, and this is a complex fraction because it's got fractions inside of fractions, if you look it over and say, what is the common denominator in all 4 pieces? It's 2. See how there's a 2 right here and a 2 right here? Barely see that. Okay, so the common denominator is 2. So if I multiply the top and the bottom by that common denominator, okay, then this 2 times this 2 cancels. And I'm left with 5. And this 2 times minus 3 leaves you minus 6. Okay, and 2 over here cancels and leaves you 5. And this 2 times minus 1 is minus 2. So it turns, let's see, 5/2 minus 3. Okay. This is supposed to be an x plus 1. I led y'all astray. What's going? How come my answer didn't turn out? Sorry about that. Go back up in here and change that to plus 1. If I get time, I'll come back and redo this video. All right, so it's supposed to be plus 1 right there. Sorry about that trouble. All right, so go back and fix the plus 1. So this would be plus 2, and you'd have then a minus 1/7. So the limit, I would fib to you and say I was just seeing if y'all were paying attention, but the fact of the matter is I have my notes over here and I misread them. Which is my fault entirely. Okay, how are y'all doing? Okay, so when you get through this, you should have sort of a list, right? When we get through, when somebody says find the limit, the first thing you want to do is, can I sub it in? Okay, can you sub in the x that they're asking you about? Okay, then if the answer is no, you go, well, maybe I can factor and reduce and then sub. Okay, factor and reduce and then try to sub in them. Okay, if not, then the next things you're going to do is we're going to have things like square roots and complex fractions. What do we do there? Different things like that. So we're going to talk about these in the next video, and then we're going to talk about what happens if we can't remove that discontinuity. And so we actually have to figure out what is going on either side of that number, because we cannot remove the discontinuity. We're going to have to adjust for that. So we will be, right now we're to this part of this what am I going to do list. If you don't have a list in your mind and you don't have it firmly memorized when you get on the test, it's just luck. And luck doesn't really overcome the nerves and the adrenaline rush that you have on a test. So you have to memorize this, be able to say it, be able to visualize it, and then you'll be doing really well on the test. All right. And that's the end of this video. Don't forget that there's a handout for factoring techniques, and then there will be a video on how to factor. And so bye for now.